Okay, good morning to all. So today I will explain about the procedure of the ARM7 program. Before explaining the ARM7 program procedure, so here we have to know why we have to choose the microcontroller in embedded system. So why we not choose the microprocessor? We can choose the microprocessor, but microprocessor it additionally require the RAM, ROM, I/O devices, timers or counters. Whenever you are taking the microcontroller, it is inbuilt of the that means it contains the processor and also inbuilt of the RAM, ROM, peripheral devices, I/O devices, timers or counters. So choosing the microprocessor means it requires all peripheral devices. That means the PCB size will be increased and also cost will be increased. So whenever you are choosing the microcontroller, it have the certain amount of the RAM, ROM, peripheral devices, timers and counters. So based on microcontroller design, so the PCB size will be decreased and also cost will be low. That means cost also very less. Okay. So here to do the program ARM7 program, so first we have to choose the Keel software. That Keel software means the Keel software version is the MU Vision 4. Open the Keel MU Vision 4, then go to project menu, then click on new MU Vision project. Okay. So here create the new project, type the project name. Suppose I written project 1, then save that file name. Okay, so here mention the NXP. Okay, so that means Philips Standard Company name NXP. So here you can select the LPC 2148. Select the LPC 2148. So here observe here LPC 2148 features. So ARM7 TDMI S based high performance. It is the 32-bit RISC microcontroller with 512 KB on-chip flash ROM with in-system ISP. Okay, here RISC means reduced instruction set computer. That means it contains only few instructions. So and also ARM7 is the based on load and store architecture. So it has orthogonal instructions. That means the instruction is to access the any addressing modes, and also it has the features. So two 10-bit ADCs, and also it has the ESP 2.0 full speed, and also two 32-bit timers, brownout detection circuit, watchdog timer, PWM unit, general purpose IO pins, CPU clocks up to 60 MHz. So whenever you are creating the new project, you have to type the NXP, then select the LPC 2148, and also you at least one time you read the features of the ARM7. Then click on OK, then click on yes, then click on yes. Okay. So here click the plus symbol for target 1, then here it display the source group 1, then click the plus symbol. So here I need to write the one program. Go to file, then click on new. So here you written the some program. So that means LDR R1 comma value 1. So this is I'm giving the example. That means here just assembly code we written, not embedded C program. For your understanding, I am explaining about the assembly line code. Here LDR R1 comma value 1, that means load the first number, then LDR R2 comma value 2, load the second number, then add R1 comma R2, add them together into R1. Within the bracket it was given x equal to x plus y. X means R1 is equal to R1 plus R2. Okay, y means R2. So then R1 plus R2. So after addition, the result should be stored in R1 register itself. Okay, suppose I was given R1 value is the 10, R2 value is the 20, then R1 equal to R1 plus R2, the result is R1 equal to 10 plus 20, then 30. That result is came, the value should be stored in R1 register. So here I should save the file name. So add give the file name dot extension C. So here we are mentioning the add dot c, okay, addition program, then save. So you should mention the add dot c, okay. So here you are writing the embedded C program. It is interact with the hardware. So here everyone know the definition of the embedded system. That means the combination of hardware and software to perform the specific operation or specific application. Okay, so you can write the C program, but C program will not interact with the hardware components. So that's why we are writing the in embedded C. So here it will interact with the hardware components. So here click on the source group. So already we written the program. The file name is add.c. So you select the source group 1, then right click on the source group 1. So then select the add existing files to group source group 1. So here select the add C, okay, add, close. So observe here source group 1, it contains the startup.s, then add.c. So here double click this one. So then select the source group 1, right click, then click the build the target. So here we written the assembly language code, okay, assembly program. We are not written in embedded C program, so that's why it is given the 9 errors, 1 warning. So we have to rectify that errors. So with the help of the we have to write in the embedded C program. This program we have to write in the embedded C program. Suppose here we written the some other program time delay like that. Suppose no error came, so that time we have to go to debug, then start the debug, okay. So then click on OK. Every program code size will be, the limit is 32K. Then click on OK. So here it display the display the one window, output window. So here you have to select the peripheral. So in that we are selecting the general purpose IO, that is slow interface. So we can select that one. So that time we can run the command. You can observe the output window in general purpose IO. So you can observe the output in that window, okay. So this is the assembly code program written. So it is not embedded C program. For your understand, I was explained small program, that is addition, okay. So next class I will explain time delay program. In that you clearly understand how to write the program, how to execute the program. You can see the output window, the program executed output window, okay. Thank you.